For this video, we're going to be specifically addressing one of our three standards in this unit. This is the standard that we have not gotten to yet, that is standard SRT 7. It states, explain and use the relationship between the sine and cosine of complementary angles. So we know that sine and cosine are our ratios of the sides in right triangles. So we've been using sine and cosine to find missing lengths of right triangles, and we just started using it to be able to find the angles in a right triangle. And it says the sine and cosine of complementary angles. Okay, complementary angles, if you'll remember from earlier in the year, are two angles that add up to be 90 degrees. So if you've got 60, the complementary angles would be 60 and 30. And remember that we call the angle that makes it add up to be 90 be the complement. So you'll hear me use that term. You'll hear me use that term in this video. So when we talk about complement, we're talking about the angle that makes it add up to be 90 degrees. So before we even start talking so much about the relationship, let's just get those numbers down so that you can start to see the relationship. So for sine A, we know that our reference angle is A, this one right here. Sine A, that would be the opposite over the hypotenuse, so that would be 2 square root 3 over 4, which simplifies to be square root of 3 over 2. Alright, then cosine A would be the adjacent over the hypotenuse, so that would be 2 over 4, which simplifies to be 1/2. Now, when we talk about sine B, that means that we're changing our reference angle now to B. So I've changed colors. So now we name our opposite and our hypotenuse and our adjacent based on that reference angle. So on this one, sine B would be opposite over hypotenuse, so that would be 2 over 4, which would simplify to be 1/2. And then cosine of B would be adjacent over hypotenuse, so that would be 2 square root 3 over 4, which simplifies to be square root of 3 over 2. So looking at this, what do you think the relationship is going to be between the sine and the cosine of the complementary angles? We know that angle A and angle B are complementary. The acute angles in a right triangle are always complementary. So if we look at sine A and cosine B, that would be the sine and cosine ratios of complementary angles, you should notice that they are the same. Looking at cosine A and sine B, again, that's the sine and cosine of complementary angles, they are also the same. The reason this happens is because when we change our reference angle, we are actually changing that opposite and that adjacent. Remember, we're having to switch those up. So when we change our reference angle, we change our opposite and our adjacent. So the sine A, the opposite is 2 square root 3, but when you do cosine of B, when we switch the reference angle, that 2 square root 3 is now the adjacent side. So the main thing that you need to take away from this is that what is that relationship between sine and cosine of complementary angles? The sine and cosine of complementary angles are the same. So sine and cosine of complementary angles are the same. Now, this sometimes pops up on non-calculator portions of tests and the EOC. It'll give you something like this. Sine A is equal to the cosine of blank. or cosine B is equal to the sine of blank. All right? Now, if you're given this picture, you should look at this and know that the sine of one angle is the same as the cosine of the other angle. So it would be sine A is equal to the cosine of B. But what if you're not actually given a picture? You can always say that it's the cosine of whatever 90 minus A is. That would have to be the complement to A. If you did A was 40, then 90 minus 40 would be 50. That would be the complement. Cosine B would be the same as the sine of 90 minus B, because that would be the complement of whatever the measure of angle B is. All right. Also, sine A is equal to cosine of B. Cosine B is equal to sine A. So if you remember that if you've got different ratios, sine and cosine, then if you use complementary angles, then they are congruent or the same.